Now we will see the new definition of carbohydrates. Before that, I just want to show you the structure of glucose. Now, glucose, it's a carbohydrate, and in glucose there is aldehyde functional group. Along with aldehyde, it has number of OH group. So we can say that glucose, it is a polyhydroxyaldehyde. Okay. In the same way, now see the structure of fructose. Fructose, it has ketonic functional group. Along with it, it has again number of OH group. So we can say that fructose, it is a polyhydroxy ketone. Glucose and fructose both are carbohydrate and they contain either aldehyde group or ketonic group along with number of hydroxy group. So the another definition for carbohydrate is they are polyhydroxyaldehyde or polyhydroxy ketone, or the substance which yield these polyhydroxyaldehyde or polyhydroxy ketone on hydrolysis. So now carbohydrates are defined as polyhydroxyaldehyde or polyhydroxy ketone or the substances which yield these on hydrolysis. Next we will see the classification of carbohydrate. Carbohydrates, it is quite complex organic compounds, and carbohydrates are mainly classified into two types, that is sugars and non-sugars. This classification is done based on their physical properties. Like sugars, they are sweet, crystalline and soluble in water, while non-sugars, they are amorphous, tasteless and insoluble in water. Best example of sugars and non-sugar, you can take sugar are table sugar, sucrose, and non-sugar, starch. So both are carbohydrates. Sugars, these are divided into two types based on their hydrolysis, that is monosaccharide and oligosaccharides. Monosaccharides, they cannot further undergo hydrolysis, while oligosaccharides, they can undergo hydrolysis and give 2 to 10 monosaccharide units. Monosaccharides, they do not undergo hydrolysis, but based on the functional group present in them, they are of two types, that is aldoses and ketoses. Monosaccharide which possesses aldehyde group, it is aldoses, and if it possesses ketonic group, then it is called as ketoses. While monosaccharides can again be classified based on the number of carbon atom. The monosaccharide which contain only 3 carbon atom, those are called as triose, while monosaccharide which contain 4 carbon atoms are called as tetrose, 5 carbon atom pentose and 6 carbon atom hexose. So based on these, we can say that glucose which contain aldehyde as a functional group and 6 carbon atom, so glucose are aldohexose. While fructose, it contains ketone as a functional group and 6 carbon atom. So fructose, it is a ketohexose. In this way, monosaccharides, they may be aldotriose, aldotetrose, aldopentose, ketotriose, ketotetrose. While oligosaccharides, as they can undergo hydrolysis and they yield 2 to 10 monosaccharide units, oligosaccharides are of disaccharide, trisaccharide, tetrasaccharide and so on. As its name, disaccharides, these on hydrolysis give 2 monosaccharide units. While trisaccharides, these on hydrolysis give 3 monosaccharide units, while tetra gives 4 monosaccharide units. These monosaccharide units, they may be same or they may be different. Now see the general formula of these. First we will see monosaccharide. Mostly their general formula will consider it as a C6H12O6. While disaccharide, their general formula is C12H22O11. Trisaccharide, their general formula is C18H32O16 and tetrasaccharide, their general formula is C24H42O21. Now how to remember these? If you compare these 4, here carbon atoms, they are in the multiple of 6, C6, C12, C18, C24. While here hydrogen atoms, here 12, they are increased by 10, H22, H32 and H42. While oxygen atoms are always half of the hydrogen atom. If it is hydrogens are 22, then oxygen will be 11. Hydrogens 32, oxygen 16 and this way. The example of disaccharides are maltose, lactose and sucrose. We will see in detail about these. Trisaccharide, example is raffinose and tetrasaccharide, its example is stachelose. So these all are sugars. Monosaccharide, oligosaccharide, all are sugars. While non-sugars, these are also considered as a polysaccharide. These are the polymers. Polysaccharides on hydrolysis gives more than 10 monosaccharide units. They may be 50, 100, 200 and so on. Based on the nature of monosaccharide units form, polysaccharides, they are of 2 types, homopolysaccharide and heteropolysaccharide. The polysaccharide which on hydrolysis give same type of monosaccharide units like starch and cellulose. These on hydrolysis gives only glucose as a monosaccharide unit. Number of glucose molecules. So they come under homopolysaccharide. While heteropolysaccharide, these on hydrolysis give different types of monosaccharide units. The best example of heteropolysaccharide is heparin.